Hello, my name is Eric Yarbrough, and today I will be giving a presentation on spaced repetition and mnemonics enable recall of multiple strong passwords. This is a presentation by some researchers at Carnegie Mellon University. So I'll kind of go in some acknowledgements at first. We have some of the main author was Jeremiah Bloki. There was also Saranga Kamanduri, Lori Cranner, Anupan and Datta. And the work was originally presented at the 2015 Network and Distributed System Security Symposium. And the paper is given in the description here. As a disclaimer, some of the graphs, tables, and sentences in this presentation were explicitly copied from their research. So all the credit goes to them and all the awesome work that they did. So we're kind of broken this down into 5 different sessions or 5 different parts. First, we'll kind of go into the motivation of why this was done. We'll also go into a little bit of the background, explore some key information within this field, and this will kind of help us build up upon the key questions that will need to be asked. We'll also look into a key study that was done and kind of see how those questions were answered. We'll look at some results and kind of see some of what information was generated, if there were any issues found by the researchers, and how it was handled. Finally, we'll go into a conclusion where we'll look at some key takeaways, and then we'll wrap everything up at the end. So first, looking at motivation, kind of in the past, for users when they want to interact with either devices or web services, they must first authenticate themselves with that service. What that means is, by authenticating, you're providing information about who you are. And this is a secret piece of information only that you know. Kind of think of it as like a key. Typically, today in the computing world, we use passwords for everything. Although we've kind of also moved on towards using two-factor authentication through text or email or some sort of authenticator services, passwords are still that dominant form of authentication. This causes a very unique issue because as the internet and the number of devices have grown, one of the challenges presented with this is that so has the total number of passwords that the user kind of has to manage. This could be like financial, social media, you name it. Like there's a ton of passwords now, or a ton of secret keys that the user has to kind of keep up with. And we've seen that, over time, a lot of users adopt very insecure password practices, and this is by having cryptographically weak passwords. This means like very short, alphanumeric passwords, very easy to break. Sometimes they share passwords between accounts, or they'll copy passwords down on sticky notes in insecure places. When we talk about these insecure practices, we also must talk about some data breaches that happen as well, because it relates very closely to it. Data breaches are very common nowadays, where hackers they compromise systems from a lot of these major companies. There are 6 listed here, but there are a lot of them, and they happen just about every single year. And sometimes it happens because of programming error. Sometimes it happens because something was misconfigured on a server, maybe the computer servers were not even secured at all. And what will happen is commonly, the hackers will take passwords as they're cryptographically hashed and salted and attempt to brute force them. So to kind of understand the hashes, you have to understand the hashing function. Hashing functions are kind of a one-way deterministic function to turn strings into fixed size message digests. And what they'll do, or what hackers will do, is they'll kind of sort of brute force and run every single combination of a password until they find a message digest that matches. And when they find a message digest that matches, they know that they found your password. And one of the issues with this is there's no kind of way to rate limit this hashing function, and it's very distributable. So you can spin up computing services on public clouds with multiple GPUs, and you can crack passwords very quickly. So it kind of generates to the computer scientists, researchers at Carnegie Mellon, we're kind of faced with two main objectives. The first one is they want to generate strong passwords, cryptographically strong passwords that have a high entropy. And that's kind of decided by a high character set with each one of the passwords, but that's also how long the password is as well. And that kind of entropy kind of gives us an accurate prediction on how long it'll take for a password to be cracked. So as a good rule of thumb, longer passwords always provide a better entropy. There's a good XKCD article presented at the end of this presentation that really kind of digs into it, and it's pretty funny as well. So we also, our second motivation is we want to have users be able to kind of memorize these these passwords into their long-term memory. So when we start thinking about this, we have to kind of start thinking about the usability of this, of memorizing these cryptographically strong passwords. So we have to kind of look at the different rehearsal requirements for a user, the revisitation rates. That's kind of saying like how many times do they have to rehearse the same piece of information, and the total number of things that the user kind of has to memorize or maintain. And the researchers identified two techniques to kind of aid in the password creation and memorization process. And this is spaced repetition and mnemonic techniques. So I'm going to go into the background. Spaced repetition. So spaced repetition is a memorization technique that kind of incorporates different increasing intervals between previous review sessions. For the example that we have here, we're using a ×2 or a doubling repetition. So each and every session, rehearsal session, it's really doubling the time between each rehearsal session. So in our example, it goes from 0, 1, 2, 4, 8, so on. And this is because we tend to forget things, in a matter of days or weeks, unless it's constantly relearns, and that kind of reaffirms it to our memory and then puts it to a place where we don't forget it. One of the main reasons why we do this is that there's a forgetting curve that was coined by a very famous German psychologist called Ebbinghaus in the late 1800s, and he actually defines out a lot of the some of the theories behind spaced repetition and mnemonic techniques. So also we'll talk about mnemonic techniques, and what they basically are is some kind of semantic encodings for the information through the use of stories or images. And one popular way that we the way that we do this is through the use of a PAO story. And a PAO story consists of 4 things. There's a person, there's an action, there's an object, and there's a scene, right? So I've given 4 kind of examples here, and it kind of creates a story almost. For the example that we're using, it's Santa throws rice at a beach. It's kind of a weird story, but that's really the idea. You know, the story really should make sense, but it should be kind of memorable. It should be kind of create this kind of mental movie in your mind, and it's makes it easily recallable when you give it certain, should we say, cues. Another example that they gave within the research is Bill Gates swallowing bike on a beach, just as another example. One of the interesting things we can do with this, though, is that we can kind of categorize this information and rearrange it. If we take 1 and 4 as kind of a group, we can create as kind of a public cue, and then we can assign the other 2 actions and objects as kind of a private action and object. And you kind of think of the public cue as something that you can just kind of have out in the world. It can be written down. You can use it to rehearse with, and it doesn't really give away your private action and your object. It almost is kind of a little bit similar in nature to an RSA key cryptography, where you have that kind of public private aspects. But we can use this private action and object to create a password with, because we can hide it, we can take it away, and then whenever we need to, maybe rehearse it, rememorize it, and then to a point where we can memorize it completely, and then we use it for our password. So by creating passwords with this, there's through these shared cues, we can take a certain number of private actions and objects and generate different passwords with them. And so if you see here, we have 4 PIO stories, each with 2 secret actions or objects inside of them. 1 action, 1 object, and then we can generate 14 different unique passwords with this. And one of the unique aspects with this is that if you say, for instance, one of these passwords were to be compromised, it doesn't totally weaken the other passwords, because even if you lose a password, each of the passwords still has at least 2 kind of unknowns that no one else knows about, that they wouldn't be able to guess. So if we kind of look into the economics of cracking these passwords with actions and objects, we see that, if we use like a pool of 92 actions and 96 objects, which was used similarly for the survey that they did, they found the offline attack to be 8470 raised to the I. The next part's the cost for the hashing, and that's divided by 2. And the passwords are kind of priced between $4 and $30, and that was through kind of a major online security firm that kind of found out that information, and through that they kind of like showed this chart of how much it would cost to basically crack a password, depending upon how many unknown action object pairs were in the password. And one of the things we kind of note is that with a hashing cost of 10 to the negative 6, we would need at least about 2 PIOs in order for the attack not to become economically sensible or profitable for someone who's trying to hack it. So a little background on the study. It was actually made this is kind of a piece of research that was from another Very similar research during the time called Naturally Rehearsing Password Schemes. And this is kind of a branch off of it. So some of the questions that they wanted to get answered was, do these PAO stories really improve a user's ability to recall the action objects, as opposed to like not having the recall in there, and how does it work out? So basically, do mnemonic methods of PAOs also work better than textual ones? So if you remove the public cues out and just give them an action object pair, does the PAO story work better for memorizing? And they also want to figure out, is there a interference pattern? So if you ask users to start memorizing not 1, not 2, maybe 4 stories, how does that compare to that 1 or 2? So is the number of PO stories that you ask them to memorize, is that directly linked to how easily they remember it? So now we'll look into the study. The study was done on Amazon's Mechanical Turk. So Mechanical Turk is a service offered by Amazon, which puts people that kind of want to have, maybe surveys or questions done, and then it kind of gives them out to real people. So these are real people, some of them live in the United States, which I believe was done for this for this survey. Basically sends the information out to them and then pays them a very nominal fee. For this one, it paid them, I believe, 75 cents for the initial session to kind of do the survey, and then kind of another nominal 50 cents for each rehearsal session. And when the survey kind of basically informed them that this is a study on memory, so don't try and cheat on this. Don't write anything down. We're just basically testing to see how you remember it over time, because they didn't want to create any bias in there with people either feeling like they have to memorize it or else they're doing something wrong. And this is a very important kind of part of their study as well. So when each one of the participants were logged on to the Mechanical Turk, they were given a assigned scene, and for this case it was a lily pad. From there they selected a person from the drop down. For us that would be Darth Vader, and they would click continue from there. One important thing to call out right here is that once you clicked on that continue button, they weren't allowed to go back and change their answer afterwards, because that would create some inconsistencies in the data. So once they selected that scene and the person, they were assigned action objects. And once we were assigned those action objects, they were asked to imagine a story going on with the PO, for the person, the action, and the object. For us, that would be Darth Vader bribing a roach on a lily pad. So from there, they were asked to select the image that kind of appropriately represented the word, and the same thing for the object as well. Down at the bottom, they were also asked to kind of type in the story as well, and they were finally asked to type in the action object 2 more times to really make sure that they memorized it before they left. There was also another group as well, specifically 100 participants were assigned to, which had a very similar backing, except that they weren't given a scene, and they didn't select a person at the beginning. This was the textual group, and they were just assigned basically an action and an object, and they were told that you also similarly, you have a little time, a minute, to memorize these words, and then what we want you to do is to memorize this and type it in as a story, and then once again type in the action objects 2 times into the form, and then click continue. And that was it for the initial rehearsal session. So then after each one of the kind of iterative sessions, the expanding iterative sessions, each one of the participants were invited back. And like I said, they were paid 50 cents each time that they came back, whether they got it right or wrong. One important thing to note is that if a participant were to miss one session, even just one, they were not invited back for any subsequent sessions. And this is because they would not have the same consistencies as everyone else. But similarly, when they were invited back, they were shown a person in a scene and asked to pick the action and the object. So each participant was allowed 3 guesses to basically get it right. And if they didn't get it right, they were shown the action object pair, and then they had to select it one more time. So now we'll move on to the results from this. Looking at the different scheduling rates, one important thing to call out is that there's a +2 start on here. So for the 24 times 2 plus 2, that means that for that group right there, they were giving kind of 2 extra rehearsal sessions on the first day. And then after that first day, they had a similar rehearsal interval as the 24 times 2. Looking at this chart, it shows the survival rates for each one of the different participants in the study, kind of defining each one of the terminologies. The successful return shows the kind of participants who got through and answered the questions for all the previous rehearsals, and then came back for the current rehearsal. The num survived is the number of participants who remember their action object pairs during every prior rehearsal, and then the division of num survived divided by num survived return shows the kind of conditional probability that a participant remembers all his stories during the rehearsal, and he's remembered and he's survived through all the previous rehearsal sessions, returned for this rehearsal session. Another thing you can see on here is that on the 4th row and 5th row, there's a interval with a -2 and -1, and that kind of means that those were the participants that were given 1 and 2 POs for their survey. You can kind of see on here, if you look at the first column, one important thing to note is that a lot of the forgetting tends to happen when the first process, and then over time people tend to forget less and less. We can look at the observed survivability in each one of the different groups here. One thing we'll call out is the mnemonic versus text group, and you can kind of see within the first, all the intervals except for the last one, the mnemonic group tends to do much better. And then on the very last session, it kind of evens out and doesn't really become statistically significant anymore. You can also see on here the mnemonic groups between the purple and the green ones. They were given either 1 or 2 PO stories to memorize, versus the purple one, which was given 4. And you can see that it's very clear that people who are given 1 or 2 stories to memorize tend to not forget those stories nearly as much as someone who was given 4 PO stories to memorize. One of the things you saw during the survey, though, is that a lot of people tended to kind of drop off like halfway through, and this kind of created some issues with the survey, with the research, because they want to make sure that the people didn't drop off because they felt like they couldn't remember the words, because if they did, then that would create a lot of bias in the system or in the results. So they sent out an email en masse to everyone who kind of dropped off at some point, and they asked them to fill out a final survey, and they paid them 25 cents to kind of find out why they quit. So they surveyed 61 people, and they saw that for the majority, a lot of people didn't respond to that survey, but for the people that did, they either did not see the email until it was too late because they were reminded to participate at that interval, or they were just too busy. So quick conclusions, the key takeaways: the best rehearsal schedule was 12 hours times 1.5, and the 76.6 participants over 158 days tend to memorize all their PO stories. Another thing, a key takeaway, is that of the PO stories, for the people for the PO stories, they outperformed the text-based group. And this was pretty much shown until the very end, until it became not really significant, super far out at the last interval. And then the third thing is that the significance, or the significant interference pattern, as opposed to people who memorized 4 stories, as opposed to people who only had to memorize 1, was people who memorized 4 PO stories tend to forget a lot more. So thank you. That is the end of the presentation. I have left a couple of links to follow up on for naturally rehearsing passwords, and a XKCD article on password strength. Once again, thank you, and thank you to the researchers as well, for all their great work.